Okay, so next page, and this is binomial distribution scenarios. So we're going to actually start getting into working some problems and actually solving them all out and using the calculator, etc. So we have the probability of having a defective item is 0.3. So they're telling me the probability of having a defect is 0.3. So that would be my success. My failure, which is going to be 1 minus 0.3, is 0.70. The lights just flipped off, so I'm sorry for that. Failure is 1 minus 0.3 is 0.70. We also have 5 light bulbs, so this is my number of trials. So what is the probability of having 0 defective light bulbs? All right, so we have a specific number. We have a number of trials, so my work shown is going to look like this. This is a binomial. Because we have a specific number, this is going to be a PDF. We happen to have 5 trials. Our probability of success is 0.3. And we want to know the probability of having 0. All right, so this is where your calculator is really friendly. Although this one is pretty easy to do by hand. All right, so I'm going to press the second button, which is this blue button, followed by the vars button, which has a little distribution on it. So second vars. Then I'm going to scroll way down to letter A, which is binomial PDF. My trials is 5. My probability is 0.3. My X value is 0. And I end up getting 0.16807. And that's my final answer. That's done. So it's pretty easy. The calculator is pretty friendly on this. What's the probability of having 1 defect? Well, once again, this is a very specific value, so this makes it a PDF. It's a singular value. So this is going to be binomial PDF. Our trials are still 5. Our probability is 0.30. Oops, that should be a comma, not a parenthesis. But we want 1 success. So here we go. Second vars, binomial PDF, 5.3, and we're changing our X value to 1. When we do that, we end up getting 0.36015. Next one, what's the probability of having 2? Once again, this is a specific number of successes because it's a singular value. That's a PDF. So it's going to be a binomial PDF, 5.3 with 2 successes because we have our trials, our probability, and we're just going to go back to our calculator. Second vars, binomial PDF, 5.3 X is 2. So we end up getting 0.3087. Moving along, what's the probability of having 3? Once again, it's a singular value, so it's a PDF. So it's a binomial PDF, and we have 5 trials. So we have a fixed number of trials, 0.3 probability, because that's not changing, and we have 3 successes. Second vars, binomial PDF, 5.3 X is 3. 0.1323. All right, what is the probability of having 4? Once again, singular value, must be a PDF. So this is a binomial PDF, 5 trials, 0.30, 4 is my number of successes. Second vars, binomial PDF, changing my X to 4. And now we have 0.08235. I'm going to go back through that one because I think I covered it up pretty badly. Binomial PDF, trials is 5, probability is 0.3, X is 4. And the probability that we'd have 4 successes out of the 5 is almost 3%, almost 3. What is the probability of having 5 defective items? So basically 5 out of 5. Again, it's a specific value, even though it's all of them, so it's a PDF. So this is a binomial PDF. 5 trials, probability of success is 0.3 out of 5. So we want 5 successes. Second VARS, binomial PDF. Trials is, or X value is 5. And the probability that we get 5 out of 5 is 0.00243. Next thing, what is the standard deviation and expected number of defects in a box of 5 items? Well, I'll be honest with you, I'm going to start with the expected value. The expected value is going to be this. That's the formula. And we know it's going to be a binomial because we have a specific number. Because we have a specific number, we know n is 5. So in this case, we're going to go 5 times our probability is 0.3, which is 1.5. We would expect 1.5 defective items. In other words, if I sampled boxes over and over and over again, on average, we would expect to find 1.5. I'm never going to have a box with 1.5 defectives. I'll either have 0, 1, 2, 3, 4, or 5. But if I sample a bunch of boxes, the average number of defects will be 1.5 per box. All right, standard deviation. Well, the standard deviation for the binomial is the square root of NPQ. So this is what this looks like for work shown. The square root of 5 times 0.3 times 0.7. And this 0.7 came from 1 minus 0.3. That's where the Q came from, 1 minus 0.3. That gives me this value right there. When I multiply that, I get the square root of 1.05, which equals 1.0247. So that would be my standard deviation for that. All right, we're going to stop the recording, and then I will begin the next page, next material. Oh no, I'm going to continue. This is, I apologize, I am going to continue to the next page with this. So suppose that the probability of having a defective item is 0.3. So in other words, we're continuing with the same scenario. So 0.3 and Q is still 0.7. That's the probability of failure, which is 1 minus 0.3. And we still have our trials at 5. So we have the same scenario. So what is the probability of having no more than 3 defective items in a box of 5? Okay, so we have, this tells me it's a binomial, but I'm going to have more than one value. And I'm just going to tell you this will change how well you do in the class. Take the time to make a number line. So 0, 1, 2, 3, 4, dot, 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 all the way to 15. So I said no more than 3. So that means it could be 0, it could be 1, it could be 2, it could be 3. It could be any one of those values. Because I have multiple values, that means it's not just a binomial, it's a binomial CDF. However, my trials are the same number. There's 5 trials. My probability is the same, it's 0.3. However, here's what I'm going to use for X. I use the highest value I circled. The highest value I circled is 3, so this is going to be a 3. So let's go ahead and do that, and then I'll tell you what it did. So second VARS, binomial CDF, trials is 5, probability is 0.3, and our X value happened to be 3 in this case. When we do that, we end up getting 0.96922. 0.96922. And that's my answer. Now here's what it did. It took the PDF of 0 plus the PDF of 1 plus the PDF of 2 plus the PDF of 3 and got 0.96922. So if we'd gone back to the page before and added up the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3, we should get 0.9622. But the CDF does all that work for us all at once, so we didn't have to do it, because if you had to do it like 20 times, it'd be pretty rough. What is the probability of having at least 3 defective items in a box of 5? All right, so first off, anytime you see at least, I want you to think 1 minus. Now we have a specific number of trials, so this means this is going to be a binomial. And 0, 1, 2, 3, 4, dot, 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 all the way to 15. So at least 3, that means 3 all the way to 15. This is what I'm interested in. All right, I'm interested in everything above that line. That's what I want. Well, that's multiple values. Because it's multiple values, that tells me I'm working with a CDF. So I have a binomial CDF. My trials in this case is 15, and that should have been 15 up here as well. No, excuse me, I lied. This should be a 5. So 0, 1, 2, 3, 4 all the way to 5, 0, 1, 2, 3, 4 all the way to 5. This should not have gone to 15. I was thinking of something else. I apologize. So this should have been 5, which is what I had. This should also be 5. So binomial CDF, trials is still 5. I'm going to scratch that out. Trials is still 5. Our probability is 0.3. Now, this is where you have to be careful. I want 3, 4, and 5. So I subtract out the highest I don't want, which is 2. And you're like, I think I should be subtracting out the 3. And it's like, no, don't take away what you want. Keep the stuff you want. You want 3, 4, 5. Take away what you don't want, which is this. So here's what I'm going to do. 1 minus second vars, binomial CDF. Trials is 5, probability is 0.3. My X value we said was 2. And I end up getting 0.16308. So this equals 0.16308. Now I want to show you something. Let's just do something real quickly on the calculator. Second vars, binomial CDF. Trials is 5, probability is 0.3, but let's change that X value to 5. Instead of a 2, we want a 5. When I do that, I get 1. And you're going, why is that? Well, I could have had a 0, 1, 2, 3, 4, or 5. X could have been any of those values. All right? Well, if I do a CDF of 5, that's the PDF of 0 plus the PDF of 1 plus the PDF of 2 plus the PDF of 3 plus the PDF of 4 plus the PDF of 5. So it summed all those PDFs up, and when it did that, it gives me this. So this is really the CDF of 5, which is my top number. So this is really the CDF of 5 minus the CDF of 2. So let's try that out real quickly. All right? Second vars, binomial CDF, trials is 5, probability is 0.3, X is 5. Enter, minus second vars, binomial CDF, trials is 5, probability is 0.3. But now I want to subtract out the thing I don't want, which is the 2. And I get 0.16308, which is exactly what we had. All right, what is the probability of having 2 to 4 defective items? 2 to 4 defective items. All right, that means once again, we have 0, 1, 2, 3, 4, 5. I drew my number line correctly this time. And that means I'm interested in those values. I have multiple values. I have a specific number here of trials. The specific number of trials tells me it's a binomial. but multiple values tells me I'm doing a CDF. But I have two values. So I'm going to subtract, I'm going to take the highest, which over here was 5, but now it's a 4. So we have a binomial CDF. Our trials are 5, our probability is 0.3, and our X value is 4, minus the binomial CDF. Trials are 5, probability is 0.3, and we subtract out what we don't want. Well, the highest value I don't want is the 1. I want that 2, so don't take away that 2 because I want it here. All right? So here's what it looks like on a calculator. Second vars. Binomial. CDF. Trials are 5. P is 0.3. Our X value, the first one is a 4. Minus second vars, binomial, CDF, trials is 5, subtracting out what I don't want, my X value is a 1, and I end up getting 0.46935. All right, that'll stop this one.